Okay, in question number 3, we've got vectors. I can see a P, I can see a Q, and they're non-zero real constants. Okay, A and B are perpendicular vectors. Therefore, I know that A dot B equals 0. Find the values of P and Q such that A, B, and C are linearly dependent. Okay, so there are the two pieces of information that I know that M times A plus N times B should equal C. So I can set up simultaneous equations. So let's do perpendicular first. Therefore, 2 times negative 4, so negative 8 plus 3 times negative 1 minus 3 plus P times 3, 3P equals 0. Therefore, 3P equals 11, P equals 11 on 3. So that's the first part done. Find P equals 11 thirds, and that's because of the perpendicular vectors. We know that they're linearly dependent, so therefore I know that M times A. So 2M minus 4N equals 2. That's using M times the A component of the I plus N times the B component of the I equals the C component of the I, and dividing all that by 2, I get M minus 2N equals 1 as equation number 1 that I'll solve simultaneously. And secondly, M times 3, so 3M, plus N times, so minus N, equals 1. And I'd like to double that and times it by negative 2, so it gives me minus 6M plus 2N equals 2. Add these together, minus 6M plus 2N N equals 2. That gives me 5M equals 3. That's a minus 2, which means that's a minus 2, which means that's a minus 1, and that's minus 5M, and M equals 1/5. If M equals 1/5, then I know that from here, N's going to equal 3M minus 1. Therefore, that's going to be 3/5 minus 5/5 negative 2/5. So N equals minus 2/5. And I know that M times, so to find out what the last bit is, I'm going to have M times P plus 3 times N equals Q. So 11 thirds times 1/5 plus 2 times 3 times minus 2/5 equals Q. So what have I got? I've got 11 on 15 minus 18 on 15 equals Q. Q equals minus 7 on 15. So there are my two answers using the idea of perpendicular vectors and linearly dependent vectors.